This is the final video in a three-part series demonstrating the process of lost wax metal casting using the Cera-Fusion ceramic shell system. In this video, we will be casting our model in silicon bronze metal by melting the wax from the shell, preparing the shell for metal casting, and finally revealing our metal casting. At this stage, I no longer need the handle on the wax model. First, I'll remove the screws securing the wax block. Then I can recover the wax by melting it in my electric pan. This allows me to use the wax in my next project. The next piece of hardware was custom made from inexpensive car jack stands, a hot air gun, and some sheet aluminium. The hot air gun is fixed to a stand and is height adjustable. On another stand, I have a drip tray where a ceramic shell can be placed. At the base of the drip tray, I capture the wax in a silicon tray. The ceramic shell is then placed on the stand and the hot air gun is used to melt the cup out of the shell. There are two main reasons to melt the cup. The first is that we recover more wax to recycle later. And two, the cup is a large body of wax that takes quite some time to melt out. If the wax above the cup starts to melt before the cup, the liquid wax starts to expand but has nowhere to evacuate. This can pressurize the shell and crack it. By melting the cup out first, the wax has an easy escape path out of the shell. Now the cup is melted, it's time to roll out the dewaxing station, which is also known as a furnace. I built this a couple of years ago in a separate video. I'll leave a link down in the video's description if you'd like to learn more. This furnace uses a thermal probe rated for up to 1300 degrees Celsius. The probe is located next to the shell to measure the air temperature. Beneath the shell is a tray with sand to capture the wax as it drips from the shell. Now let's take a moment to discuss the temperature profile we're aiming for. First, we need to preheat the furnace to 500 degrees Celsius. Next, the shell will be placed into the furnace and the temperature held at 400 degrees Celsius for 8 minutes. During this stage, the wax will evacuate the shell and the shell will acclimate to the temperature in the furnace. Then we ramp up the temperature at a climb rate of 50 degrees Celsius per minute until we reach 700 degrees Celsius. Once there, the temperature is held for 3 minutes. 700 degrees Celsius is an important temperature target to hit for a couple of reasons. The first reason is that the carbon soot left from the wax must be burnt off, and this doesn't happen until we reach this temperature. The second reason is the shell becomes harder and stronger at this temperature. So now we know the theory, let's fire up the burners. This furnace is very well insulated, so preheating it to 500 degrees C only takes a couple of minutes. Now I quickly place the shell into the preheated furnace and restart the burners. Then all I have to do is follow the temperature profile I discussed earlier. After completing the temperature profile, I turn off the burners. It's important to leave the furnace closed to allow the shell to gradually cool down. Once the shell is cool, I can remove it from the furnace. And this is what the shell looks like after burnout. Now I can move on to preparing for metal casting. The shell is placed inside a stainless steel container and is packed with dry sand. The sand supports the shell during metal pouring. It's important to choose a container that closely fits the shell. If the container is much larger than the shell, you'll end up with a lot of extra sand between the container and the shell, which means the shell might not get up to temperature during preheat. Ideally, you want no more than 50 millimeters of sand around your shell. A lid is placed on top to prevent debris from falling into the shell. The container is then placed inside our furnace, and our target temperature for preheating the shell is 700 degrees Celsius for around 30 to 40 minutes. Now remember, back in the first episode I weighed the wax model. This model's weight can be used to calculate how much metal we need to melt to fill the mold. Since we know the density of the castable's LSR wax, we can convert our weight in wax to volume. And once we have the volume figured out, we can calculate the required amount of metal. We will be casting our model in silicon bronze. The metal is then placed inside our furnace to be melted. Once the metal is up to temperature, we're ready to pour. After allowing the bronze to cool down for several hours, we're ready to unveil the casting. The bulk of the shell is removed by striking it with a small hammer, being careful not to hit the metal casting underneath. The residue of the ceramic shell can be removed with a wire brush. However, I'm going to use my sandblaster, which is much quicker. After sandblasting, this is what the final product looks like. Before we wrap up the video, let's check out an example of what can be made using the Cera-Fusion ceramic shell system. This is a classic Kiwi icon, the beloved Buzzy Bee children's toy. We immortalised this classic design in silicon bronze, resin and power shell using the products you've seen in this video. If you would like to learn more about any of the products featured in this video series, visit us today at castables.co.nz.